Good morning, everybody. I think we'll give it a few more minutes for people to continue to trickle in, especially those poor souls on the West Coast. Alex Guyard has volunteered to take notes. I'm sure that he would appreciate if anybody else wanted to join him in the CodeMD. There's a link on the top of your Metaco or from the agenda page, the data tracker agenda page. Especially because I believe, Alex, you're one of the presenters on S-Frame, right? So we might need somebody else to take notes for the period while you are presenting. Okay, good. And Bernard seems to be bouncing on and off, so maybe he's having network issues, so maybe we should wait until he's ready.
And this is Barry. It will be your stand-in AD for this session. I think it's 4 a.m. for Murray. So no, here Murray just came on.
All right, great. Just give Bernard a few more minutes. Hopefully he'll be back soon. I'd rather not run it entirely by myself, but I will if I have to. All right, I guess I'll get started. Hopefully Bernard will be able to join soon. Not quite sure what's up there. He was briefly here, but then showed disconnected, so maybe he's having network issues. So anyway, welcome to Avtcore at the virtual IETF. I am your chair. Bernard is hopefully your other chair soon. Alex Guyard is taking notes in CodeMD. If anybody else wants to help out there, I'm sure he'd appreciate it. Let's see. Meeting tips. hopefully, if you're already successfully here, you know most of these things. Please use your headphones when speaking, if possible, to avoid echo. Other thing, let's see, yes. And you can enter the queue by using the raise hand tool. You'll need to unmute yourself manually. Video is separate than audio. Video is appreciated if you want, but remember you have to unmute audio also separately. Note well applies. Hopefully everybody's familiar with this. If not, you can follow the links on this slide here, or go to many other places on the IETF website. It's hard to miss it if you go to the IETF. Here are the links to various things. The Jabber room is bridged here in the web in the Medico, so if you don't need to do anything special for that, it's just there in the dialog balloon tab. And if anybody if anybody is not able to talk out loud for whatever reason, maybe your family's asleep, we can say mic in the room if we can have a volunteer to relay. Anybody want to relay from the chat? If not, I'll try to keep an eye on the chat. That'll be hard if I'm the only chair here. But anyway, yes, and also Dr. Alex. Yes, Barry?
Jonathan, I'll keep an eye on the chat.
Great, thank you. Okay, here's our agenda. We've had a few tweaks for things. So if anybody has any comments, let me know. Got a few working group items that are going to deal with relatively quickly, and then spend most of the time on S-frame RGB encapsulation. Anybody have any comments on that? Good. All right. We've had a number of drafts published since the last IETF, so that's very exciting. Many of those were cluster 238, so that's even more exciting. Good work. Keep doing work. We've done pub recs on multi-party RDT mix. We've had a few working group last calls, many of which will have commentary on. We have one expired draft we're going to mention in a moment, and we adopted 3-day work items. Frame marking, we had an interim meeting and had a consensus on this that we're planning to move it to experimental because of its implementation status. And we're removing the dependency of VP9 on it. This was the discussion on the list. So there's still a few items to resolve, but I think we're going pretty well there. I don't think we have this on the agenda, but I don't remember. Mo?
Yes, I did just publish an update that copies all of the VP9 information into the things. And I try to dig into the issues that the implementer reported about VP8. I think we need to drill down to a little bit more, because from what I can tell, it's nothing to do with VP8. It's in both VP8 and VP9, and it's really a non-issue. I don't see anything that mandates SFU rewriting of anything or requirement for incrementing by one. So maybe we need to follow up on the list and figure out what really needs to happen there, if anything.
All right, yeah, so probably let's raise that on the list.
Yeah, I opened a thread this morning on it.
Sounds good. Yeah, so if anybody has any comments on that, please respond on the list. the Tetra draft. The chairs emailed the draft. It expired more than a year ago. The chairs emailed the draft authors and no response. So our proposal is to drop this milestone and work item for now. And if interest returns in this, always obviously be adopted. Does anybody have any objection to this? I'll mention this on the list also, but sounds like there's no objection. So that's good. That's it for the chair items. Now I'm the first person on the agenda. Should hopefully be relatively quick. And so unless there's anything else on the chair items, I'll move on to that. So status of this, we published draft 11. All the authors have finished after working group last call. All the authors all acknowledge their BCP 7879 obligations. We have Krister raised a few issues during working last call, which will be on a slide in a minute. There are some IPR disclosures, which I'll also mention, and our proposal is to send the pubrec after 12, so unless there's any objections to that. Mo?
List about what looks like an omission in the VP9 draft. I don't know if it was intentional or not, but something that was in VP8 was omitted in VP9, and it impacts frame marking, and I think it'll impact anything similar to frame marking, like AV1 dependency descriptor or anyone that wants to do any kind of intelligent marking or analysis of the VP9 streams without having to get really deep into the bit stream. Basically, it's difficult to identify whether something is a reference frame or not, just by simple inspection of the headers. You have to go pretty deep into the bit stream to figure it out. And I'm guessing that may be an omission or an oversight because it was there in VP8, and maybe just fell off the table in VP9.
Yeah, I think part of that is whether it's a somewhat of a complicated question if something is once you have temporal scalability. I mean, because are you going to want people to rewrite is as a dependency for the layers that are actually being forwarded? But I'll take a look at that in more detail. I mean, I don't think we want to try to actually change bits of the wire at this point, given how much VP9 deployment there is. But I'll try to take a look and see if I can figure that out. I mean, it maybe that you do need to dig into the actual VP9 bit stream, which I agree would possibly be unfortunate, but I'd rather not change the. Like I said, we've got a very wide deployment of VP9 at this point, so I'd rather not change the bits on the wire if possible. But
yeah, I think the biggest thing is to figure out. The biggest thing is to figure out whether it was a conscious decision to omit it from VP9, whether it was a mistake. I think that would be the first.
Yeah, I mean, I guess my question is: are people actually? I think it was the people who were those of us who were designing the excuse me the VP9 bit stream didn't have any use for that flag, so we didn't see. I think we didn't. I mean, we didn't think of it when we designed it because we weren't using it. So I guess the question is are people using that flag from VP8 rather than using temporal scalability, which serves, I'd say, much the same purpose to a somewhat with somewhat more flexibility, but might be better to answer this on the list when I'm more awake. And Bernard, I see you now. Are you actually here now, Bernard? Because that would be awesome if you were.
Yes.
Oh, excellent. Good. Yeah, I saw you were bouncing in and out before, so hopefully you're stable now.
Yeah.
All right. So next week we do have some IPR disclosures on the VP9 draft. So
Yeah, I had sent those to the list earlier, and they have been posted as they came into the list that they related to. So the question for the group is there anything that the group thinks we should do about this? We did not hear anything, any suggestions on the list, or should we just go ahead? So is there anyone, let me put it this way, is there anyone who objects to moving forward with VP9, given the disclosures that we've seen? Did anyone put up their hand? I don't think so.
I don't see anybody.
Is there anything in the Jabber room?
No.
Okay, I think we have our answer.
And finally, we have, so Krista raised some questions on the SDP issues. As a meta issue, he sort of raised that we probably should be sending these things to the SDP directorate, but we didn't, so we'll try to do that, more of that going forward. But specifically on this, he raised some issues on the SDP negotiation. My proposal, there are three parameters on VP9: profile ID, max frame rate, and max frame size. My proposal is the profile ID needs to stay unchanged and answers updated offers. If you want a new profile ID, use, negotiate a new payload type number. Whereas max frame rate and max frame size are declarative. Either side can add it or change that in either an answer or an updated offer. And then relatedly, we don't actually say, Christopher also pointed out there wasn't any language saying what, somebody who receives an SDP and does a media sender actually has to do in response to these. And the important question there is whether max frame rate and max frame size, you should not or must not exceed them. Excuse me. So I'd say there, my inclination is to say, would be to say should not. But I see Justin in the queue, so he can give some other opinions. Justin?
Should is probably appropriate here, simply because of the fact that primarily it's a pixel rate limitation if one exists, and like for screen share or something like that, you may find yourself exceeding like one of these dimensions. I think just it's like a pretty heavy hammer, given that this is largely advisory.
All right, that was my inclination too. So I guess, like I said, the other important question is, for both of these things, do browsers, will any existing browser implementations choke, or will they just treat this as advisory and we'll try to decode everything? I mean, my suspicion is they try to decode everything, but I just wanted to make sure that was the case. Are you still in the queue for Justin, or no? I need to remove you. All right. So yeah, so it sounds like I'll make that a should. I'll just make the rest of these. I'll just send one more comment there, and I'll publish draft 12. And then our belief is that we don't need to do anything further. We don't need to do any updated working group last call, because these are basically just the resolution issues from working group last call. So we'll do a pub rec once the 12 is out. Well, I guess once we also do address the issue that Paul raised. All right, so that's it for that. And next we have JPEG XS.
Everybody, I hope you can hear me well.
Yes.
So this is about the RTP payload spec for JPEG XS content. So next slide. The WGLC announcement is concluded on February 23rd, And there were 5 responses, 3 positive and no objections, and there were 2 questions. Most of the questions came from Christer regarding the SDP, and 1 came from Inge, also regarding SDP. So next slide, please. Thank you. The SDP questions from Christer were about the section 624 in our RTP payload spec, which basically contained just a single sentence saying that all parameters are declarative, but we rewrote it to be more correct and more informative, contain more information to describe what we actually want. So that's a rewrite, and it's a full paragraph that was added to the document. And then there was a question on optional versus mandatory parameters, but we believe that this was already clear in the text, because we really have one part where it says like mandatory parameters, and then another part it says like optional parameters. So I don't think this was really an issue unless we misunderstood the question. So to be clear, all parameters are optional except for the rate parameter and the transmode parameter. And then we used wrong terminology in the text, so we replaced the wording of SDP object everywhere with the SDP media description. I think that's correct, unless somebody tells me it's not. Please let me know if it's not correct still. And then from Inge, there was a remark. Basically, one of the optional parameters, the interlace parameter, was accidentally spell corrected to become interlaced in revision 7 of our draft. So I changed this back to be interlaced again as is intended, and this reflects with the other RTP standards and also with the SEMT 2110 specification. So it should be interlaced. That was a good fix. And then we also had a small side question on the clock rates. So indeed, we specified originally that the clock rate should be 90 kilohertz, but this took like an extra liberty, and I think indeed the comment was correct that it's better to say it must be 90 kilohertz. So we changed that and made it a mandatory setting. And I submitted draft 09, which addresses all the questions and remarks normally. So I think, yeah, the text is done, and I would like people to review it maybe again, or to move it forward in the pipeline. So that's it. Thank you. I just want to add, I don't know what the next step would be, so that's a question to the chairs. So if they could point us in the right direction, that would be very, very helpful and appreciated.
Well, how about submitting a draft with the SDP changes you describe here?
The draft 09, so I did that.
Oh, okay.
Yes.
All right. So then the next step, I guess, would be chair review and publication request.
Yes, if that's possible, yes.
Yep, that sounds. Would Bernard and I will figure out which? Go ahead.
Please put that in the minutes so we know what the next step is on everything. Thank you.
Okay. Yeah, and if any questions pop up, I'm available at your disposal, so let me know. Thank you.
So yeah, so we'll chairs will do our chair review, make sure everything's reviewed, and then we'll go with publication request, and we'll figure out whether Bernard and I are driving that one. All right, next is Cryptex and Justin.
Okay, so we published a new version of the draft just the other day. The 01 version of the draft, or the 00, is a working group document. 01 basically changes the name of the parameter used to negotiate support for cryptex and SDP. We had a discussion on the list a month or two ago, and A equals cryptex sort of came out as like the prevailing option. That's been incorporated to 01, and there's some other editorial cleanup. Next slide. Yeah, so the one thing remaining right now is inclusion of the test vectors, to demonstrate proper encryption using cryptex into the document. Once we have that, I think we should be ready for a last call. Sergio is currently working on those test vectors. So I think, for a last call, we should be looking at it. This period between now and next IETF would probably be a good time to start that. That's everything.
Cool. Anybody else have any comments? If not, hopefully we'll be able to get that done soon.
Justin, do you think we should be ready for implementation very, very soon?
For implementation?
Yeah.
Yeah. I don't know the time frame of when that would be actually implemented within Chrome or whatever. No longer my exact sort of remit now, but I've discussed it with the team here, and probably something that we'll start to look at in the coming months.
I see Sergio.
Just to point out that there is already a developer for FTP implementing cryptex with the test vector that are used in the spec, and also by Jonathan in his GST implementation. So it should be just a matter of adding the attribute and not much.
Yeah, as Sergio said, I have an implementation for the Jitsi SRTP library also, though it's not wired up in the rest of the system yet.
It's good to hear.
All right, that's it. Next is EVC.
Check. All right, radio check. Can you guys hear me? Hello?
Yes,
Hello?
I hear you.
Oh, that's great. Okay. All right. Morning. Get a cup of coffee. So this is going to be a quick update for UBC draft. Thank you already. So just kind of a quick recap what we have decided for UBC draft a couple of meetings back, just no person parquet, and also no support of a multi RTP stream is mixed with a multiple transport, and also no database signaling for residence support. So that is all have been great for I believe it was 2 meetings back. And the last two items, no support of frameworking. That's really the decision co-author made since last intro meeting agreement. Since frameworking will move to experimental. So that doesn't make any sense for us to support it anymore. And then also we remove the slice loss indication and also the PSI support. That's also basically trying to align with the BBC BBC draft. Next slide, please. Next slide. So UBC draft was adopted as a working group draft since 108. We recently very honored to have a Yongkai from Samsung as co-author. I'm not sure if Yongkai want to say a few words after that, so I will leave it to him. The recent revision, which is the 01 working group draft, we mostly focus on the UBC codec specifications. We think it's getting there. There's only a few edited notes left, but I think we're gonna get it done on this codec specification part very soon. Next slide, please. You actually skipped one. Yeah, there you go. So there are still a few placeholders we're trying to address in the draft. And the major thing we have left, which is Section 7, the optional parameter for the STP. We believe we have agreed that the EVC pillow draft will be following VVC, and VVC draft is almost getting there. We have a new version, which is going to talk about later, has most of the parameters down. So we actually going to start to fill up these blanks in the EVC draft. Let's agree that we're probably going to follow closer to the VVC draft. So it's really, I think it's reasonable for us to target working group law school around summer 2020. At that time, I think VVC should be done already. I mean, working group law school, hopefully. Yeah, that's pretty much things. We only have 2 revisions since 109, and that's all the updates I have. Any questions? Oh, Yunke, I'm not sure you want to say a few words, and it's up to him.
Well, this is Young Kwan. Thanks for having me as an co-author of this important, internet draft. Personally, I've been involved in Avtcore more than a decade ago when Avtcore payload format has been first introduced. I'm really happy to come back to this working group, and I will do my best to quickly progress this one in the right direction. Thank you.
Thanks, Yunke. We're happy to have you here. Well, I think that's all for UVC.
That all seems very reasonable to me. So, I mean, hopefully, we'll make good progress. Thank you.
Yeah, I think the working group last go around summer, it's really reasonable for us without stretching too much of deadlines.
Sounds good.
Thank you. All right, so me again, good morning. Here's the update for the VVC. And next slide, please. So we did 3 revisions since 109, and most trying to, there's lots of echoes. All right, so most trying to address the editor notes as we promised since the last meeting. There were 24 of them, so lots of them. But we're getting pretty good progress. Only, I think, 4 or 5 left at this moment. Revision 08 is actually late submission just a couple of days ago, so I doubt anybody has time to review it. In this slide, actually summarize what have changed from 0708, and mostly 08, because the summary changes on 07 has been sent out by email. That was a while ago. I think next slide, please. This is kind of quick recap what happened in 07. As I mentioned, we have a new one, 08. That was 07 is the first batch edit nodes we're trying to resolve. Basically, OPI and SV parameters. Stefan was sent out a really detailed rationale why we want to do that. So I don't want to just kind of repeat whatever he said already. So if you do kind of forget that email or somehow miss it, please just go back to that email. If you have any comments, we do love to hear that. So since there's no comment we received during the review period, we actually implement whatever we have proposed during from the meeting discussion. Yep. Right here. Yeah, right here. Okay. As I mentioned, 08 was a new submission, so please go ahead and review them. We did more than a dozen updates, and I probably don't have enough time to go through each of them, but here I'm just going to kind of bring up some things that we think is very important. But I will do send the update from the mailing list. Looking forward to the comments. So 3 things I want to mention up here. So VVC draft is already in the final publication stage. We pretty much finalized the VVC code information in section 1. I think it's great progress. And we also made the same decision not to supporting free marking. I think this is also reasonable. And we actually, from last 2 meetings, will be asking working group opinions regarding if we should remove the SLI and RPSI, RTSP feedback mode and no support. So from our point, we don't see the usage of that, and we simply remove that. The one last thing I want to mention in this meeting is really the reserved R bit in the fragmentation unit header. That's also something we brought up a couple of minutes back already, but we never proposed anything. So in this meeting, I have a slide to discuss the things we propose for the R bit. We can talk more in next couple slides. Next slide, please. Next slide. Yeah, right here. One of the things we actually wrote is one of the informative notes under the market bit for the RTP payload header. The similar content, which is because we copy paste from HEVC and then make a line with VVC, but the co-author just found the confusion is about it is actually bit to the benefit. Therefore, we decided to remove it to make this much cleaner. But let us know if you think you have different opinions, and we can discuss that through the mailing list. We also removed a few STP parameters inherited from HEVC, and things like a maximum video bit rate and picture size, buffer size, etc. Just from our experience and the co-author think there's less usage or practically no usage at all from HEVC. So we decided not to support it. Again, if you have any different opinions, we do want to hear that. And maybe we missed anything, so we don't want to do that. Next slide, please. Next, here we go. So here's the reserved RB that we talk about in the fragment unit header. So we brought this up since 107. So the proposed text in the following is really from our production team. They have their usage. So what we proposed here is really we're trying to say use the R bit to identify to signal only the last the last null unit in the fragment unit header. When it said it's 1, the R bit simply said is the last null unit for the fragment unit header, or equals to 0, which is not the last null unit header. It's a similar, I would say the concept wise is similar like the M bit, the market bit in the RTP header unit. But we don't see much of usage for marker bit for the video side. Maybe we missed anything, but that's the current conclusion we had. And we think that's a pretty good usage for the R bit. Otherwise, just leave it blank as called the reserved. Again, sorry, we don't send this early. Do provide your comment in the mailing list. See if there's anything it is right usage or not. And next slide. That's going to be the last one. So we only have 4 edit nodes left, down from 24, which is great progress. And we only have one large section, which is STP offer and answer sections, which is not going to be very difficult since we have all the STP parameters already. And we are targeting the working last call around June 2021. I think probably earlier than that, but I think June should be a good time. And that's all for VVC.
Yeah, I wanted to thank you, by the way, for making good progress removing things that weren't required. That's actually makes the spec much more readable now.
I think that's the design philosophy we agreed at the first meeting, to trying to simplify the process. So I think we are doing that. Thank you. right? Should it be offline, right?
Yeah. Right. I just had one comment. I mean, I'll probably better to erase this on the list, but on the R bit, I'm curious how your use of the R bit interacts with the spatial. I assume you have spatial scalability. So I'm curious whether that's last bit of the whole picture or last bit of the spatial layer, or last fragment of the spatial layer.
If we want to go back to one last slide, one slide up. Yeah. So it's actually for the whole picture. Instead of the coded picture, it's going to be a whole picture.
All right. Yeah. So all right. Well, we can just put that on the list.
Yeah.
Okay.
Appreciate that. Okay. Thank you. No comment.
Any other comments on this? Or should we move on? Let's go on. All right, now the big topic for here. We're a little bit ahead of time, so that's good because I think this will probably take a fair bit of time. So, oops, sorry. I keep, like I said, my slides tab seems a little jumpy, so I apologize if I'm suddenly on the wrong slide. So, who's presenting first?
So do you want I start a little bit and then you take over? Or
okay,
yeah,
sure.
Okay. So I'd like to present a few slides and up to getting to a set of requirements that with Sergio and Alex we gathered, and maybe from there take questions. So next slide.
So we'll hold the queue until UN is finished, or UN and Sergio have gone through these slides.
Yeah, 5 slides, I think, also. Next slide. So yeah, the question, why a codec packetizer? Why should we try to evolve the current architecture? So there are products like Google Duo or Jitsi that are inserting a transform step between encoder and packetizer. And they do so for a good reason, which is to achieve end-to-end encryption. And I'm sure we're all excited about that feature. That said, they do that currently in a very ad hoc way. And that's true, we can say it relies on a few hacks, as presented, as the link is showing, and what was discussed in IETF 109. So we think it would be good to rationalize what is being done by these products, make sure it stays as consistent as possible with the RTP ecosystem, and at the end of the day, provide either technical solutions or guidelines. So with Sergio and Alex, we looked at that, and we thought that the current architecture, like the RTP media pipeline, we can probably adapt it to allow these products to do what they want to do without too much changes. And that's why it's relying on this idea of a codec agnostic packetizer, and the proposal we are trying to explain now. So at last Avtcore meeting, and also on Tuesday's S-Frame meeting, there were a lot of questions on this packetizer and how it would deal with AVC or redundancy mechanisms. So we have slides that are explaining that, and I will present some of them now. Next slide. So first, how is it working with like the simplest example, H264 or VP8? So we have a typical start with, you take a raw frame, you encode it, and then the encoder is producing 2 things. First, it's producing the content itself, the frame, the encoded frame, and it's also generating metadata. Then in a browser like Chrome, there will be a transform which is implemented in JavaScript, where the encoded frame and the metadata will be exposed. And the transform using JavaScript will typically encrypt the frame. with the current API design, the metadata is read-only, so you cannot change it, and that makes sense. So after the transform, now we have some transform data. So in the slide, it's in red, and we keep the same metadata. And the transform data there is no longer valid H.264 valid VP8 content. But the metadata is still applicable to what was the underlying content. So the idea for the packetizer there would be to use the metadata to generate precisely the RTP headers, the head extensions, and so on. And for the payload to split the transform data using a heuristic. And the current heuristic is to use the MTU to produce as little as possible a number of packets. So I just want to point out also that the metadata, it can be also audio. So for instance, the voice flag that you can find in some RTP head extensions is typically produced by the encoder. And you cannot use the transform data to try to generate RTP head extensions like the voice flag or any kind of RTP head extensions, because it's encrypted basically. And that mirrors well what any proxy will also have to deal with, meaning a payload that is encrypted and just use the RTP header data to do its processing. Next slide, which might be a bit more interesting, is what about VP9 SVC? So there it's very, very similar. We have a row frame, and the encoder will produce, like in this example, 3 subframes. So probably a base frame and then 2 dependency frames. And each subframe is related to some metadata. So you have subframe 1, subframe 2, subframe 3, and each one has its metadata. And then there will be a transform. And again, the transform will be applied separately to each subframe. And so you will have transform 1, transform 2, transform 3, and so on. After the transform, the packetizer will first deal with transform 1 plus metadata 1, and it will produce a first set of packets. Again, it's the same strategy. Payload is done you packetize with MTU, and you only rely on metadata 1 to generate headers. And you first transmit the base layer related packets, then the dependency transform 2, then transform 3. And in a typical case, they will all share the same timestamp, like in a single stream, single transport case. So in the draft, we do not have any notion of subframe. We just call them all encoded frame. And it's really the role of the encoder to output individual independent frames that can be transformed individually. Next slide.
Second, I put my hand up to ask a question about 2 slides ago. Is it all right to ask a question?
I would prefer to go to the requirements. So there's only 2 slides, and then we can take you if that's okay.
Okay, thanks.
So getting back to the point of Cullen in last meeting, in Tuesday S-Frame meeting, where we do not remove any, like there are 2 places, 2 different processing. There's a codec specific processing, which happens before the transform, and a codec agnostic processing that happens after the transform. The transform itself can be codec specific, or in the case of S-Frame, we hope it will stay codec agnostic, because that's simpler. But clearly, the RTP media pipeline is codec specific, and the codec specific processing can even be application specific in the sense that there we are saying VP9 will produce 3 different subframes. You could say an application will tell its H.264 encoder to produce 2 subframes as well in whatever heuristic they want. And then the processing pipeline should be roughly the same. And the last slide before taking questions. So with Sergio and Alex, we gathered some requirements and we listed them. And we hope the current proposal and the current small changes in the architecture are actually fulfilling these requirements. The first thing is that we do not want to disrupt existing mechanisms like the mapping to RTP streams, redundancy mechanisms, or existing feedback mechanisms as well. All of that should work well, and maybe they could be optimized later on, but that's fine. They should still be usable out of box. And in terms of applicability, we really want it to be able to apply it to simulcast, to support single RTP string on a single media transport for SVC. We also think we need to do negotiation there to negotiate that payload format. And we also think that to succeed, this payload format should be complemented with whatever side channel information like RTP head extension that will allow the SFU to perform layer selection and packet forwarding precisely on these RTP head extensions and not on the payload. So Cullen, since you're in the queue.
Sorry, just took hitting unmute a couple times to get it to work. Okay, so can you go back a couple slides? Anyway. Maybe forward one slide. This one might be easier. So first of all, the describing the packetizer as being after isn't really accurate. This is sort of wrong. I mean, the encoder, what came out of the encoder had to be packetized before it was at some level of packetization before it got passed into the transform. Okay, there may be further packetization later of a different type, but it was packetized up there. And my concern is around having two places to put information. So like the whole idea of some sort of generic type, information content for generic for codecs, like at some level, I don't think we'll ever achieve it. There will always be things that come up anew, like when we move to holographic content, when we move to even the 360-degree stuff probably would need some metadata that isn't covered by the current draft. So there always will be extensions to it, but I do like the idea of, like, particularly for, flat 2D codecs, we should be at the point of getting pretty good at this. So like I support the general idea, but the question is about, does it go in the payload section or the header section? And the RTP architecture, we've really gone down that this goes is the header is where we put this information. And I don't see that as being very incompatible with this information. I just think that here, basically, you've already packetized at the encoding, at least partially packetized. You're passing into a transform. And as long as the transform can modify the header that's going to end up in the RTP, as well as the data that's going to end up in the thing, that's just like an implementation detail of your specific implementation. It's not like something we should drive the whole standard by. And you should just do that. And then the transformation, then we can have this metadata sitting in the header data where we already have, like, a whole bunch of stuff to do it. And the reason I like that better is I'm really worried about the case of having the data two places and not matching. And that will inevitably happen. And I think that's, that this is just trying to flip the architecture of RTP of where we put this information to be completely wrong. And that you don't need that for any reason. You can just put it in the right place and have the same information you have right now. And that's no big deal. So could you talk a little bit about where I'm going wrong on that whole sort of set of assumptions?
So first thing, you're saying there's a first step of packetization. So a packetizer is generating an RTP packet, and that's the definition
No,
of
a
packetizer. So
packetizer is
doing
turning
like,
a stream of data out of a codec into a set of chunks of data.
yeah. So but I agree. It's chunking the data, and the encoder, either the encoder or the application is doing that. And what we are seeing is that the chunking is really application specific, right? And as part of the chunking,
Do
there will be
you
some
mean application specific or codec specific? That's a big difference there. Those are two very different things.
So to me, in our use cases, it's codec specific. But I don't see why some applications would not be able to specify, like, yeah, I want to use H.264 in a specific way, so that this tile there, it's its own subframe, and I will put it separately. That's fine as well. I don't want to preclude it. I don't want to define it either.
Right.
So about the data being somehow redundant, if you look at frame marking information, like or dependency descriptor, you will have it like, is it a frame or not? It's in the RTP header. It's also in the payload at some point. And so there's already redundant data there. And that's fine. One of these redundant data is for the SFU. And the other one is for the end recipient. And we need to extract some of the information from the user, the encoder, to the SFU. And this extraction should be carefully studied because it has privacy implications. And I would like us to provide guidelines there so that we say, okay, this particular information is not privacy sensitive, it's useful for the SFU. So yeah, let's allow it. Or let's say that, yeah, you can use it, it's safe. And this information, maybe not, like audio level, maybe not, things like that,
Yeah, look, I agree with you that. I think that my question is about why that data needs to somehow now, though the RTP architecture is to stick that in the header, why it now needs to be somehow stuck in the payload. That's my question. Like, why don't you do the same thing but stick it in the header?
No, but we are putting it in the
We are
header.
doing that. Yeah. And if you look at VP9 packetization, somehow you have the information in the payload that it's a keyframe, and it's also in the RTP header. And what we're saying is that since the payload now is encrypted, we don't care whether it's there or not. We will not use the payload information, and we really need to put this information that is really crucial in the headers. So I'm not sure I'm clear, but I think we agree.
Okay, well, there's a bunch of people lined behind me. Let me go here.
Bernard, you want to say something?
So yeah, I would like to follow up on what Cullen just asked. And here's my framework for asking these questions. There are actually, I think your architecture maybe is a little bit too tied to the insertable streams architecture. But even within, if we're just talking about the Chromium code base, right, there's more than one architecture because you can also do this with web codecs, where you actually get access to each of the encoded chunks, you can call them encoded frames, and you have the ability to build your own RTP header, as well as getting access, potentially to the payload. So, and the reason I'm asking this is that, and following up on Codec's question, Cullen's question about application versus codec specific, is we've just heard, for example, that some of the codecs will not use frame marking. And the issue I think that comes up when we discuss this is the metadata isn't necessarily going to be encoded in the RTP header the same way for every codec. For example, for something like H.264 for AVC with temporal scalability, you might find frame marking is fine, right? But what we're saying here is I think there's an issue if you're saying that every codec will have its metadata encoded the same way in the RTP header you're going to get into issues there. Whereas in the web codec kind of a framework, right, you can get the metadata. The metadata actually comes as part of the encoded frame, but then you can do with it whatever you want. You could decide, I'm going to take this metadata and output frame marking, or I want to put instead dependency descriptor in the header, or anything else that the IETF or anyone else might come up with. So that yields a different conception here. So I would just ask you to try to be clear about what codec agnostic means exactly. Does it really mean that everything is the same for every codec? I think that kind of is a promise that might be difficult to fulfill over time. Or does it mean that just the generic process is somehow the same for every codec, but codecs might handle it differently? I just think, not asking for an answer right now, but just to think this through.
I can provide a temporary answer. And that's maybe something we are discussing with Sergio, and we do not align precisely, but I think it's a very good question. My understanding is that the genuine processing, like the processing that we're seeing there, could be applied to any codec. The packetizer itself, like the construction of the payload using NTU, can be codec specific. Now, the fact that you use one RTP header extension for one codec and another RTP header extension to transmit the metadata for another codec, I'm thinking that currently we should not close the door to anything. It would be ideal if we could just have the one RTP header extension that would fulfill all codecs. My understanding is that it's very difficult, and that's fine. And I'm not sure that existing implementations currently need it. For instance, implementations using H.264 or VP8 might stick with frame marking, and as VP9 or AV1, they will use the dependency descriptor. If we have a good proof in the future that the dependency descriptor is a good fit as well for H.264 VP9, then it's even better. I don't think that decision impacts how we define the packetizer and the payload format, because we have an extension point, which is RTP header extensions, and we can combine the payload format with various RTP header extensions. And basically, it's the application designer that will do that at the end of the day. Jonathan?
All right. Next in the queue is an individual. So I feel like you are making life too easy for yourself by showing the encoder half of this picture. I feel like if you showed the decoder half, then a lot more of the complexities would be apparent. In particular, because basically the decoder process, which is to say the depacketizer, I mean the detransform hopefully is obvious, but the reassembly in particular, and then before the decoder proper, is where a lot of the complexity arises, which you need to worry about. So in particular, the thing that you need to be able to do is to be able to tell as a receiving pipeline, do I have all the, have I received, have the packets I've received, do the packets I've received contain enough information for me to successfully decode a video frame, or do I need to knock something and wait for it to come in before I actually feed things to my codec?
Right. Yeah.
And so, in the process of arbitrary packet loss and packet reordering and so on and so forth. And so that's where I think a lot of the trickiness is going to arise. Now, if you say you always have something like AV1 decoder description, that's probably sufficient. If you don't, then I think you need to figure out how that works. And that's where a lot of, especially in the, sorry, go ahead.
Yeah, so that's true. And I thought about adding slides for the decoder, but I was maybe too lazy. And it's true that the encoder is a good example so that we can start precising all these issues. So I can go ahead with providing information for the decoder. You're right about the packet reassembly. So in the VP9 AVC case, maybe Sergio can correct me if I'm wrong, but you will set the marker bit that will tell you, okay, you got transform 1, you should not expect to receive transform 2, and then you're good. And
Yeah,
that's how you would do things.
Yeah, that part is relative. Go ahead.
Yeah, that first is that the current draft, at least, we plan to use the AB1 dependency descriptor that provides that information. But anyway, I think that it makes it probably just, well, we are using AB1 dependency descriptor that should be able to cover that.
Right. Yeah. So, I mean, I think, reassembly within a frame is relatively easy. It's across frames. You've had a burst loss. You don't know what you don't know whether those packets you lost contain a reference frame or not.
Well,
And
it is.
so,
I think it is what AB1 dependency descriptor.
Yeah. So, like I said, if you have the DD, then that's hopefully sufficient. But
yeah, because that's exactly what the dependency descriptor try to provide,
So,
is to know exactly if you have received a frame, if that frame or subframe in a special scalability codec is decodable or not, without having to check any further data.
Right. So yeah, like I said, if you assume you always have DD, then but I think that.
But hold on 1 minute, Jonathan. Right, you may have the DD info at on the sending side here, right? Because you could decide to encode that metadata with DD and send it, but you might not, right? If you're doing frame marking instead, and on the sender you got the DD info but decided not to use it all and just do frame marking, then you might not have it on the decoder side. So I think your question is valid still.
Yeah, I think so. So we need to figure out if there needs to be at least some minimal information at the in this itself. And then relatedly, as you mentioned, if your question of whether how things are chunked into the stream are, you seem to be saying, to the question of whether it's codec specific or application specific, if it's an encoder choice, how the raw media stream is chunked into the pre-transformed frames, then you need to figure out how much of that decision does the reassembly pipeline need to know. Can it just, does it need to be prepared for any chunking decision whatsoever that the encoder might have felt like doing, or do we need constraints in the spec of what encoders are allowed to do?
Yep.
Right. So yeah, I think those are the big things, and I think Colin is next.
Hi. Yeah. So I am a little concerned that for something which is supposed to be codec agnostic, all the discussion we are hearing is of a very small number of currently popular codecs for interactive video applications. And RTP is used for a lot more applications and in a lot more different scenarios and with a lot more different types of codec than we are just currently hearing about. And we hope it will continue to be used in a bunch more scenarios in the future. And I think I'm not seeing something which is really codec agnostic. I'm seeing something which might work for a small subset of current video codecs.
So if you take the previous slide and replace H34 VP8 by Opus, it's working fine. And for instance, audio is less of an issue there. There's less of metadata to provide to make it work, to make end-to-end encryption work. And we want to have it in scope. So we definitely want to have audio and video. As of other kind of metadata, maybe we could think of subtitles, time text, for instance. So currently, my understanding is that it's more sent as part of data channel in WebRTC environments.
But not every
but we could definitely see it being used there in the same manner.
But not every application that uses RTP uses WebRTC.
Yeah, but anyway, but I mean, this is not meant to be a replacement for RTP packetizers. I think that in fact, if we talk about later in the spec, we are only going to make the negotiation of the codec agnostic packetizer to be done within or together with the normal packetization. So it is this is not precluding or preventing to use any other codec or packetization that it is already available or featurely implemented, but it is only meant to be used when you are using S-frame or other transformation that may encrypt the content, so that you cannot use the standard RTP packetization.
But in that case,
I would also say frame marking is a RTP head extension that you may want to use or you may not want to use in your application. Frame marking does not make any sense outside of a given scope, and the payload, this packetizer there would make sense for some applications, and for some other applications it's not really applicable, and that's fine.
But no, I don't think it is fine, because if you're trying to define a payload agnostic, codec agnostic format, it has to be codec agnostic, and it has to work for all codecs, because RTP is a generic framework.
So for some given definitions of encoders and decoders, yes.
Yeah.
But
just so it's
at least
no longer codec agnostic, it works for a particular subset of codecs.
Yeah,
Okay.
we're trying to...
you're, for example, thinking of real-time text and things, other stuff that it is not audio and video?
I'm not even convinced it works for all audio and video codecs.
We're hoping to have it work for audio and video codecs, at least the ones that are in use or will be in use in WebRTC environments.
Yeah.
No, I think that it should be. I mean, I would like to. The idea is to be able to work with all the audio and video codecs, not real-time text, for example. So that's a reduction in the scope of the agnostic packetization only for audio video. But I would like to know do you have any concrete example in mind that we will have to check?
Just one question from the chair. I think we've had at least 3 questions about the meaning of the term codec agnostic. And I think I would suggest that needs to be clarified in the draft, because for something that just the meaning of that term, I think Colin had that question. We've had at least 3 questions about that. So especially when you start talking about differences between codec and use the term codec agnostic, it's a bit confusing. Thank you.
Yeah, I mean, it also seems that in order to decode this and in order to packetize the media sensibly, you need to know what is the underlying codec, and you need to know how whatever the equivalent of a null unit in this particular codec, or a frame, or an independently decodable piece of the codec output is. And all this is payload format specific. It's all codec specific. And so unless you're just arbitrarily chopping according to the MTU, which is, of course, a very bad idea for performance, you need to know the underlying payload type. And the signaling for RTP is also based fundamentally on the idea of knowing the payload type. Now, I think the idea of end-to-end encryption of the payload is a perfectly reasonable one, and we've seen a number of examples of different applications and different organizations defining ways of doing that. But this seems like something which can be done within the existing RTP model of payload formats which identify a codec by defining a common way of encrypting the output of particular codecs. And it would seem that can be made to work with these middle boxes and these selective forwarding units in a way which is compatible with the architecture. So I think before throwing out the entirety of the way RTP has defined media handling and the entirety of the way RTP and the associated signaling specifies codecs, it would be useful to see if we can make this work within the existing architecture. And I see no reason why we can't do that. So I think rather than just diving straight into throwing away the entirety of the last 25 years of work here in defining payload formats, we should think about, you know, what are the actual requirements, and is there a solution which is compatible with the existing architecture?
So from what I understand, what you're asking for is saying, so you propose something, is it efficient? And can we compare it with another way of doing things that would be codec specific? Let's compare it apples to apples. And then if there are some advantages on one side, yeah, let's go for it. And if there are advantages on the other side, yeah, why not also specifying it? Is that correct?
I'm saying that the RTP architecture fundamentally relies on knowing the codec and fundamentally relies on things being codec specific. And I think you can achieve your goals in a way which is generic and works with the middle boxes and allows you to do the same sorts of transformations whilst doing it in a way which fits with the architecture. If you try to design the system that way, rather than making the assumption that you throw away the existing architecture.
Yeah, I think as Colin just said, right, something like SRTP would be considered codec agnostic, but that doesn't mean everything in the SRTP architecture throws away the knowledge of codecs.
Right. I think it would also be possible to define a common way of transforming a payload and signaling that such a transform has been done, and using a different payload type to indicate that. And that would also let the decoder know how to decode it. Without having to
so to be clear, that's what you just said, Colin. That's the thing that is codec agnostic. The rest of it isn't.
And that's somehow one option that is described in the draft.
No, but I think that what Colin is saying is something different. I mean, what I think that is what he's asking is for a frame to not work on a frame level, but work on a per packet level. So I think that it is reasonable, but I think that this frame must change to be able to implement this.
And that's why I was asking about efficiency, because we can do this approach where it's per packet S-frameization or per frame S-frameization, and we'll see there will be differences in terms of efficiency as well. And that's something that people might
I'm not sure that's necessarily true. I think that would be an implementation. That would depend how you implemented it.
I think here the question is going back to the fundamental issue: is if we do a per frame encoding, per frame encryption, we need to have something that it is agnostic, because the packetizer is going to be handling encrypted data, encrypted media data. If we go to a per packet encryption, then we may reuse all the RTP.
I don't agree that is true. I think you can split, I think this can be done in an agnostic. I think you can encrypt a frame at a time and split the resulting encrypted frame up in a way which is consistent with the RTP architecture, and signal it in a way that's consistent with the RTP architecture.
But for example,
would you be willing to help in defining that?
Because, but I mean, I have studied that, and it is difficult to do it. I mean, for example, in H.264, you will have to encrypt each of the null independently. In BP8, you will have to leave the first bytes of the payload. So it is a very huge effort. I mean, if we want to go there, it was also the first slide when we explained why the current packetization does not work with the current codecs. And also, I don't think it is a good thing that you are saying that you are going that you are sending normal, for example, H.264 data when you are just sending encrypted data.
But nobody suggested that. What I am suggesting is that you send a payload format, a payload type that indicates that this is encrypted H.264 data, rather than a payload type that indicates that this is a generic encrypted data, and that way that it works.
But that's what we are. That's what we are doing.
Yep.
But then
we are not.
But
we have not yet been able to present that. But we are doing that. We are saying that we are sending H.264 encrypted data.
It's in the draft. Yeah.
But then it can't be codec agnostic. That's what I fundamentally
There's some bits
understand.
that are codec agnostic.
If this is codec specific, then it is a payload format and it's defined in the usual way. And if it's codec agnostic, then it's throwing out all that architecture.
So what we are saying is that we do not plan to have to define an H.264 encrypted payload format, but we definitely want the stream to acknowledge two things. First, it's encrypted using S frame. Second, it's H.264.
I am really struggling to see how this works with the signaling and with the architecture.
Well, it would be good if we can get to that slides to be able to explain it.
Maybe you should. Maybe you
Colin,
should go
on
to
the draft chapter 4.
To freeze the queue where people is let the queue drain and then let Sergio go on with the presentation.
Yeah, sounds good. Stefan?
No.
I cannot hear you.
Can you hear me now?
Yes.
I cannot hear you again.
The danger of implementation-driven standards work, really. As nice as this may be normally here, there's just too many oversights. So on the terminology front, I think we have something like a semi-codec agnostic. It's agnostic for certain codecs, but agnostic to certain codecs, but not to other codecs. So the applicability here of this technology is limited to a number of codecs, and what they want to do is to create a mechanism that would work with all the codecs they had in mind when they were doing this thing, but hopefully without assuming or without hoping, against hope, in my opinion, that it will apply to all future codecs. And we have already had an example. So the example here, why it wouldn't work with future codecs is for AV1. I just heard from the thing that Jonathan pointed out that you need the DD in order to make sense of this type of stuff in the decoder when you have scalability. There are tons of video codecs which do not necessarily have the same concept for temporal scalability, at least, as the DD, right? SHVC doesn't have a DD. The video parameter set doesn't express everything the DD expresses. The VVC doesn't do that. EVC doesn't do that. So don't tell me that your generic architecture would work with these codecs when during a brainstorming session of a few minutes, it came already out that it would not do it. No, but I also understand that you will want to express that an
that a middle box that's making use of this can cope with a limited set of codecs, and not only with H.264 or H.265 and or VP8 and VP9. And you also want to express, and you also don't want to replicate the same thing in multiple documents specific to, say, H.264 and H.265. So, okay, the way to do this would be, don't call it generic, call it, or make an applicability statement. This specification is intended to and believed to work with the following codecs, and then comes a list. And in the title, tone it down a little bit, and then go for it. That's how I would approach this generic versus non-generic problem. Thank you. I have one other comment, and that is let's not forget that the vast majority of bits that are going over RTP in this world today are not WebRTC bits. And I know WebRTC is the IETF technology and blah, 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 but let's not forget that the vast majority of interactive video today is not using WebRTC. And I would not want to use this type of drafts as or I would not like to see others to use this type of drafts as a pusher for IETF technology for no other merits as being a pusher. Thank you.
So I agree with you that it will be very difficult to come up with SFUs that could be implemented in a fully codec agnostic way. And we're not trying to solve that. What we are trying to do is to migrate the information that might be codec specific from the payload to the RTP header extensions. And you took the example that the DD descriptor will be good for AV1, and we think so. We are not saying that the DD will be good for all codecs. It's then up to the application to use what we're proposing and select the right RTP head extension that will cover the cases. And hopefully, the header extension that we are planning to use will be supporting enough codecs, enough video codecs, enough audio codecs, that there will not be a huge replication effort. But certainly it will evolve. So I also agree that we should remove the name agnostic. It's definitely a term that is not specific enough.
Also, I would be interested in knowing the specific details about BBC and how this codec does not work with the dependency descriptor. I mean, because I think it's interesting. So if you can provide in the list how the dependency descriptor may fail to include the data from BBC, it will be great.
It should not be particularly hard to come up with examples why the technology as currently specified would not work.
Then could you provide those, please?
I will try. I'll try.
Thank you.
So that said, you know, you can't. I think if you are going in the direction of trying to create, of trying to resurrect your dream of creating something generic, at least to the known codecs as of this day, then I will try to do some work there. But don't expect me to specifically argue with you about whether this is true or that is true. if you were continuing to exist that this is an agnostic thing, then it's your burden of proof to show that it is agnostic, and not by my burden of proof that it is not agnostic. You see my point? Yeah. So I'm helping on best effort basis, but not on a on an obligation basis. Thank you.
Justin?
Yeah, so I think it should be fairly clear that the packetization is possible to be generic. The packetization is fairly straightforward. In terms of basically how it breaks up packets to fit within MTU, and I think it can be argued fairly easily that things that produce essentially datagrams can be generically packetized. The only other sort of requirement that's being placed here is that there can be some way of splitting the metadata and the payload. And assuming that can be done for a given codec format, then the actual payload can then be packetized using this generic packetizer. So the question that then remains is, can the metadata be described in a generic way? And I think that's what a lot of people are sort of latching onto here, of can this packetization be generic or not? Because it definitely is a complicated problem as to whether or not the metadata for all codecs can be described in a generic way. I think that's a totally reasonable thing that people can differ on. The thing is, though, I don't think that is really fundamental to this document here. It's if you have a generic format for metadata, then it makes the SFU's life easier because it has a single way to look at what's coming in, and then it can then act on that accordingly. But even without a generic metadata, the codecs could still, SFUs could still sort of work in the way they do today without end-to-end encryption, where they're forced to go look at these pieces individually on a codec specific, in a codec specific way to determine what their behavior should be. And there, even if we, still had things that did not fit the generic packetization or generic sort of metadata, SFUs could continue to do that. So what I would want to do is just sort of say, okay, take that off the table. S-string can still be useful, even if it doesn't have a completely generic metadata, because it still allows the transmission of the end-to-end encrypted formats and the separation of metadata and payload, which is the main things that it's required to actually work.
Yeah, I completely agree with you. Also, just one thing, that the metadata that it is needed is only the one that the SFU is requiring for work. I mean, we are not trying to provide all the metadata in the world in a codec agnostic world. Only the specific data that is required for the SVU to work.
Exactly. Yeah. Now, whether that can be fully generic is still an open question, but I think that we have a good set that seems to work for, codecs that are known today. And even if there are ones that kind of go beyond that tomorrow, like I said, it's not really a critical issue. SFUs can deal with this custom metadata. The only critical piece is that you have things that produce packets, and then those packets can have their, metadata and actual payload separated. And I think that, all the codecs that we're talking about can do that.
Can I just respond to that very quickly?
Colin, please go ahead and respond to that, and then I'll go after that.
So I'm not sure I agree with Justin's statement that we can build a generic format. I think at the minimum, you need to know where the independently decodable units, the null units or whatever it is for that codec, starts and finish. So you can packetize it in a way that you don't split these units across packets. And that makes it codec specific. You need to identify the codec, so you know how to decode it, how to decode it. And as Justin said, you need to separate out the headers and the metadata information from the payload. and from the encrypted content. And this is fundamentally what RTP payload formats do. And this is the fundamental point of the payload format concept, is just even if all you're specifying is how you split this thing up into pieces, how you label them, and how you separate out the contents from the headers. That's what a payload format does. It doesn't have to be more complicated than that. So I think you're just describing an RTP payload format, and I think rather than fight against that architecture, just accept that what you are describing fits within the architecture and work with the architecture rather than trying to throw it away.
Can I just respond to that?
Okay, go ahead.
Yep.
I mean, I think that, those things that you sort of mentioned of, yes, we do need to be able to identify the individual units, but really every payload format is doing this. And it does seem kind of strange that, every time we have a new format, we have to go define really the exact same transforms, for that particular format. When, if we got a structured sort of input from the encoder that sort of said, here are the frames and independently decodable units, then you could have a fairly generic way of describing that on the wire. And I think that's really all that's trying to be done here. That if you have this meta information that describes what it is you're trying to packetize, you could then have a single packetization format to basically fit this into RTP packets and MTUs accordingly, and then separate out the meta information so that stuff is not encrypted for the SFU. That's really all it is, and I don't really feel like we're throwing away RTP here. We're just basically saying, here's the same thing we're doing every single time with a new payload format, and trying to come up with one way where we don't have to redo this all over again for every single encrypted / format tuple.
So define a common way of doing that fits with the existing set of payload type names and the existing mechanisms for signaling what's the content, rather than throwing away that.
I mean, well, that's what we have here. First of all,
Justin, let me break on this. I don't think that is what you have here at all here. So let me try and give some very pragmatic suggestions to get to what you're saying. And I think this gets to the heart of my comments. Is one, I think that we mean very different thing than packetizer. I think that what most people here mean by and this is just terminology. What's important is we line up on what we mean, okay? But taking the stream of bits out of the encoder and figuring out the logical places to break them based on things you'd want to lose. So breaking them at Nally units or whatever the moral equivalent of that is in your codec is something that's happening on the top half of the slide that's currently displayed. It's happened before the transform, okay? And that is what most people think of packetization. I understand there is also a point where we take things that are larger than the MTU and split them to be smaller than the MTU. I understand that's how you're using the word packetization, but I think we should get a different word for that second transform where we slice them smaller, because I think that's causing some of the confusion in the discussion. And then, look, no one we all sort of have as far as one thing is about packetization, and then we're going to talk about metadata for a second, and then S-frame. So packetization, I think, with some confusing terminology, which is really not helping the conversation here in a huge way. Then, because packetization is inherently codec specific, there's no way for packetization to not be codec specific, right? In the way I define packetization. Obviously, splitting up things on MTU size is by definition guaranteed to be codec agnostic, right? I totally agree, right? So that's part of just a terminology confusion. Then we have the metadata. So look, audio levels is already a great example of, for audio types, a fairly generic, works with most things I can imagine of type audio media way of sending that up to the SFU. That's great. I mean, I don't think anyone would let's do some of those for video as well, whichever ones make sense. We don't have to claim that they work for every video type ever. We could say look, here's some ones, we believe these ones work for the list. Here's a header, here's a definition of some metadata, and we believe it works for at least these common WebRTC video codecs, and we suspect it'll probably work for some 2D video codecs in the future. And video codecs get figured out or not. We don't have to to pretend that it'll work for all video codecs that haven't been defined yet or not. We don't have to pretend that future video codecs might not need additional metadata for the SFU for some reason, right? And we'd get what we want here on the metadata. And then the third thing is with S-frame. I think that part of what's causing confusion here is we're sort of overreaching on a generic transform here. Well, I think that what I see we need to do here is be able to indicate in the SDP in some sort of negotiation way or whatever, you know, that like, look, this this VP9 was S-frame encoded. And let's just step back a little bit to think about like what would be the way, if that's all we wanted to indicate, and we wanted to be able to do that for a bunch of the major video and audio codecs, how we would do that in the SDP to indicate it's S-frame. Now, I think the other thing here is, you know, is the unit of encryption span multiple RTP packets, or do we do it per RTP packet? Okay, sort of the frame versus the other issue. And I keep hearing the efficiency issue here, but for the where the overhead's high is actually the audio packets because they're small, right? And actually it makes no difference. It's exactly the same whether you do it per, because it's small, because the audio packets are always smaller than an MTU. There is no efficiency difference between doing it for every RTP packet and for every frame. For the video packets, I mean, when you're talking about, we're talking about adding one extra IV vector or something maybe. I mean, it's a very small amount of bytes that we're adding as overhead. And maybe you gave me the estimate the other day. I mean, we'd add 1 or 2% bandwidth if we encrypt for the large video packets, if we did it per RTP versus per frame. I think we should really seriously reconsider that decision and think about if it would make more sense to just have the S-frame applied on per RTP packet versus per frame. But to Colin's point, regardless of how we come across on that decision, I think that we can easily define a solution that continues to work. So, you know, and part of the reason I like about that is it makes the losses of the packets more decoupled from each other, so that it makes some of the recoveries and other things easier to deal with. But you know, anyway, there's pros and cons to that. But the saving 1 or 2% bandwidth on large video flows is just totally irrelevant. Like I see no gain in that whatsoever. So let me just let you respond to that sort of stuff. The authors respond to that, try and clarify things. But that's how I'd like to think about how we could really make good progress moving forward on this.
Okay. I mean, I think that was, I agree with a lot of what was just said. Sort of just jump right ahead to that. I mean, I think that we should agree on what is meant by packetization. The authors and I've been using the term of basically taking something that's already been broken up into, you know, now use with equivalent, and then how do you put that in the wire? And I think most of us agree that, you know, once you have now use, putting that in the wire is fairly straightforward. I like Colin's representation of like the audio levels as the same type of thing we're trying to create here for video. I think that's a really good analogy, and I think that, you know, it's something that's worthwhile to pursue. As it relates to, you know, the actual sort of encryption and the overheads, I would, you know, still disagree that 1 to 2%, you know, savings is, you know, worthless. You know, there are people who work on transforms for codecs and spend like, you know, big parts of their careers to save 1 to 2%. But I agree, it's not the driving factor, you know, here. It's an additional bonus. And I think that the chief benefit of processing things as frames rather than as RTP packets is largely just the logical separation. That if you can split it across multiple frames, like you're not forced to, you could break everything into slices so you have better independent recoverability. But if you want to send it as an entire large iframe, then you can amortize this encryption overhead. And I think that's entirely nice, because then it separates the encrypting the video frame versus encrypting the packets as two different things, because they're in two different layers, which is an actual correct description of the situation. Anyway, you know, I think we talked about this.
I'll buy that.
Yeah, I think it's
complicated.
yeah.
Anyway,
I think we'd like to move on to see the
think
rest of the
we're mostly
presentation.
in agreement here, so I'm going to move on. But I think there's something we can work from here.
Okay, so as Jonathan said, we'll let Sergio and Yuen finish their presentation.
Sergio, do you want to take over from now?
Yep, let's go quickly in the rest of the presentation. So, couple of next slides, I think 2 or 3 more. Okay, next slide. Okay, so this is what we were speaking about packetization. We are no one before that. So the idea is that what we will get from S framework for the transform is a blob, is a binary blob that we don't have as it is. If we are talking about S frame, it is going to be encrypted, so we don't know what are the boundaries of any underlying codec, obus or null units or whatever. So what the packetization is going to do is to split this blob, these bytes of the frame into several RTP packets. And as we don't have any boundary that we have to preserve, because if you lose one, you need all the packets in order to be able to decrypt the original frame. And the packetization will just split them into several RTP packets, just ensure that they don't exceed the MTU. And the last one will be set, the market bit will be set according to as the same as it is specified in RFC 3551. And in case of the video codec is supporting special scalability, each of the spatial frames, whatever the call is in the specific codec, because there are different names for each in BP9, AB1, and things like that, will be sent with in order. The special layer will be sent in order, and the last one with the same RTP timestamp, and the last one in the RTP packet will have the market bit set to 1. Yeah, next please. So the idea is that as Colin was as Colin was saying, that we are not going to just negotiate this new packetization format on its own. It will be always relying on the negotiation on the standard one. And in order to try to reduce the amount of payload types that we are having in the SDP, because we have already in WebRTC at least, we are already using the payload types in the 35 range and things like that. So we are going to use a single payload type for this generic packetization format, and then it will be needed to multiplex the codecs inside this payload type. So this we are doing that by sending the original or the associated payload type in a header station that will cause a minor network overhead, and also it requires to negotiate different the generic payload types for audio, each one for a different clock rate for audio. So next slide, please.
Before we go on to the next slide, I'm a little confused here because the payload type is the way RTP identifies these things. So why introduce another level of multiplexing when we've already got an identifier here?
Because if not, we'll have to duplicate or triplicate the number of payload types. And I think that in WebRTC, we may exceed the maximum limit. I mean, it's just, if I have to say, I think in WebRTC we have 20 or 30 already payload types. So going to 60 is a no-go, because at some moment in time we will reach the point that we cannot, we don't have any free payload type to use. So that's what we have decided to use, a single one, and just have to include the original payload type within it.
Just to mention that the draft is exposing various ways of doing the same thing, some of which would require more payload time being consumed, some of which would require less. And we are certainly interested in getting feedback there in what would be best appropriate. So we're presenting this approach, which we think is fine. We know it has some drawbacks, but we think it's fine as well. And we welcome reviews of the current draft for the other alternatives.
I mean, I think a lot of the problem here is that the payload types in RTP are defined to be media types, and I'm not sure that, I mean, essentially you're signaling application/architect stream and then multiplexing everything inside it. And
yeah. I think we should let Ewan and Sergio finish and then open the queue again.
Mm-hmm. So just very quickly, so we can take questions again. I mean, yes, so we are using a single, instead of, for example, doing like what we do in RTX, that in RTX we have one payload type for RTX for each of the media types or the codec media types. That is causing the payload types to be double. If we use the same approach with this generic packetization, we will have to triple the payload types. And again, this is in WebRTC, when with all the H.264 profiles, BP9 profiles, BP8 profiles, we are reaching the limit when we cannot have any free payload types anymore. So that's what we have decided to do, payload type multiplexing. We can just use one payload type per codec, but then we may have the problem that it is not implementable. So this value, what it indicates is what is the original format of the generic packetization. If it was H.264, it was BP9 profile 2 or whatever. So next slide. So it just be covered in a header extension, just and as we have one extra byte, we are going to use that byte to indicate. For audio is not really useful, but we can avoid having to send more information in a metadata header extension for the SVUs in case that it is not an scalable video stream. So what we have tried to use is this extra byte to indicate when specifically if it is an iframe, so the SVU can start forwarding this specifically the video packets from these packets and on. So next slide. So regarding the frame metadata, what we have discussed before, I mean, what we are focusing is what is the potential metadata that we need. Specifically, I think that we should focus in the ones that help the SVU to do the layer forwarding and selection, and the ones that helps the recovery mechanism to work in case of loss. I mean, for example, if deciding if a packet that has been lost was actually required for decoding the full frame, and we have to take some actions about RTX, or even request a picture load indication or a layer refresh request. And this is mostly for video. And for audio, maybe the one metadata that could be used is the opus doc to know the frame length that could be used in recording scenarios. There are several solutions that could be used, like for example, trying to get back frame marking and study somehow. Use AB1 dependency descriptor, that it is the one that it is currently proposed in the draft, and we think that it fits with which it has been required. And I would like to hear if there is some scenario that you think that it will not be covered, or we can try to design a new RTV header extension for things that are not covered by the AB1 dependency descriptor. So next slide. So there is, regarding redundancy, this does not require an exchange to RTX. It will just keep working with NAC and RTX as it is working today. FEC, both ULP FEC and Flash FEC will also work. The only thing, without any change, the only thing is that now the heuristic that it is done by the application to which packet should be more protected or not is has to be changed a bit in order to reflect that the payload is encrypted, and if you lose one packet, you will not be able to recover the full phrase anyway. So it has some consequences, but it is in how the applications decide how the FEC heuristics are applied. And next one, that it is the last, is just to red can still be used. The only thing is that the redundant and primary data will be the content that has been encrypted. So in red will not, the encryption will not be applied to the full red packet, but to the redundant data parts. And there is a overhead in this applied by the transformation, because you will have the overhead and the frame headers for the redundant data and the primary data. So will be so basically you are sending the data twice. And there is a small limitation that we have when using what we call the association payload type used for multiplexing in an RTP header. Thus, red only allow us to have one header. So this header and the value has to be applied for both redundant data blocks. So it makes that you cannot send one block that it is Opus and one block that it is I don't know. So it has to be both of the same codec. That it is only it's the only limitation that we have. That if we think that it is important to solve, we can move the payload the payload type for multiplexing into the payload, and it will also work.
So at this point, Sergio, I think we're almost out of time. We only have 2 minutes left. So what I'd like to do is just try to understand from the working group how we move forward. But one way, since we are exhausted even more than the hour here, should we be thinking about an interim to get into this, to allow some more time to get into this, say like sometime during late May? Does that make sense? I don't know, Jonathan, if you have an opinion before our time runs out.
Yeah, I do think that some sort of interim would probably be useful to get into discussion of this. Obviously, there's a lot of interest and not a lot of convergence, which sounds like sort of the area where an interim is sort of ideal. I mean, we can work out the timing on the list if we do various whatever the software is.
In the meantime, I would encourage for people to read the draft and also start sending emails on the mailing list issues to the current working draft, so that we can continue in the mailing list, not waiting for the interim.
Okay. Okay. I think we're just about to be out of time for this session. So maybe, I don't know, Jonathan, do you want to take maybe one final question, and then we can call it a day?
Yeah, I mean, if either Colin, you're first in queue, so if you have something that can be handled in 1 minute, but I know, I guess he dropped himself out. Mo, I guess if you have something quick or go ahead.
Yeah, just something quick. I think we're all probably more concerned about the same things than we realize. A lot of the stuff that Colin was mentioning, it really is mostly applicable to the new codec that I presume the people that presented this care about, which is 81. I think maybe people don't realize that 81 is basically identical to H.265 as far as high-level syntax. It has the same NALU structure, and it has the same subframes that H.265 has. There's tile groups. You could split a picture into tiles and slices and things like that. So I think we need to, all agree that we're on the same page about the richness of the new codecs that we do care about, and figure out, did RTP make a mistake in providing packetization for that richness, and we really don't need it? Or is there value in that richness and we need to somehow preserve it even when we have end-to-end crypto happening? And I think the people that want to deploy AV1 should take a good hard look at the AV1 packetization to figure out, do they care about any of those things, or are they willing to forego them in end-to-end situations?
Thank you very much, Mo. And I think on that note, we will declare the session at IETF 110 over. Thank you, everybody.